Thank you to the people that pointed out to me that March 6th video wasn't showing up. For some reason it was set to private, so it wouldn't show up, so I just switched it to public, so now it should be out there in the world. When I accessed it, of course, I could see them all. I just didn't notice it was like a little lock picture on it, so I'm like, shit, I forgot to... I don't know why it saved itself as private. Okay. So are there any questions from homework stuff? We've gone through section 3.4. Of course, 3.4 would be your favorite, right? The word problems. Students always hate those, but I'm hoping if you follow those rules, hopefully it'll be a little bit better.
Okay, did 3.1, but I'm stuck at 3.2.
Okay, so you got to come see me.
I know,
Okay.
but I did the equations. It says it has more equations. I did the equations. It did just don't know how to put them. Like,
Okay, so you got to come see me, especially before the quiz.
I could show you the equations.
Yeah, not right now. Okay. So any other questions? Anything from homework? Yeah.
Number 21.
In
Section
3.4.
3.4.
Oh yeah, good. All right, I'm not going to write this all out. So it gives you this long thing in English. 3 times the difference of some number in 5 amounts to the quotient of 108 and 12. So 3 times the difference of... All right, so I know eventually I'm going to have to do what with 3? Multiply. But I don't have yet what I'm multiplying it by. So I better write that first. It's 3 times the difference of some number in 5. How do you write this difference of some number in 5?
3 times minus x. 3 times minus x.
So it's 3 times... I guess I'm not going to get away from writing this all. The difference of a number in 5. And then there's more to it. Let's just focus on that. Right? That is, believe it or not, English. So 3 times the difference. So I don't know what to multiply by 3 yet. I got to write this out first. What is the difference of a number in 5?
X.
Don't bring the 3 into it.
Minus 5.
The difference of a number in 5 is x minus 5. Now I want to take that difference. I want to take the whole difference and multiply it by 3. 3 times that difference. If you write this, what did you multiply by 3? Just the number. It doesn't say 5 less than 3 times the number. It says 3 times the difference of blah, blah, blah. So when I read that, I can kind of see the parentheses. They want to be there because it's got to show me what the difference is. Here's the difference. I want to take that whole thing and triple it. And the rest of it says amounts to the quotient of 108 and 12, I think it is. Yeah. So amounts to would be what? Equals. The quotient divided by. So that'll be the 108 divided by 12. And then you got to solve it. So of course, if you set it up incorrectly, you ain't never going to get the right answer. So that kind of sucks. Yeah.
Be 9.
The answer would be 9?
Yeah.
Let's find out. Not sure. No, when you say that, what do you mean? The answer for what?
9, 12 times 9.
Good. I love it. So this piece is 9.
9.
I'm with you.
So x equals 9.
No. What equals 9? This whole thing equals 9, right? You simplified what that was. Now what do I do on this side?
Distribute.
Distribute. Right?
3x minus 15.
3x minus 15. I like it. 3x. Multiply 3 times negative 5. Minus 15. So who's in the wrong place now?
15.
And I've told people, cover this part with a piece of paper so it doesn't go in your brain. Because I don't care what that is anymore because I've got a better form of it. So look at what you got now. This dude's in the wrong place, so I have to add 15 to make him get out of there. Right? I don't want him there. He's in the wrong place. So add 15.
30.
What's negative 15 plus 15?
0.
0. That's why we did it, so we can cancel it out. So what's left on this side?
3x.
3x, 24.
So x equals 24.
No. What's it
Divided
say?
by 3.
7.
3x equals 24. How do you kill that 3? Divide. X equals 8. Cool. Whew.
So then to check that, if you just plugged in 8 for x,
Good.
you would find out if you were
You
right or
throw 8 in for x and you see if it works out. And sure enough, when you throw an 8 in here, what's 8 minus 5? 3. 3 times 3.
not. 9.
And that's what that is 9.
So if you would have set it up wrong, it wouldn't have worked.
If you would have set it up wrong, you would have gotten an answer that would work in your equation,
But not.
but it was the wrong equation in the first place, so you did it right. Yeah.
So we don't have like to do that. Just if we have like translate, just the first step, right?
Well, it said translate, then solve.
Oh.
Yeah, so you have to solve that for the next step.
304 or 303?
3.4.
Oh.
Yeah.
I need to check.
Bravo. So anything else from homework? All right. Yes, sir.
Student, chapter 3, page 176.
Which number?
Section 52.
Number 38? No, which number?
Right here. This
Number
x,
52?
yeah, this x equals 5. Negative 35 equals 7.
Oh, 5 minus 35, okay.
So that these negative 7
Careful. What operation did you do?
divided by 7.
But what's it say to do? What operation is right there?
Oh, negative.
Subtraction. Yeah.
Subtraction.
So what's 5 minus 35?
Equals 30.
What kind of 30?
Negative.
Negative, I love it. So it's negative 30. On this side, you still have the 6x.
And then that'd be 5.
What kind of 5?
That'd be positive 5. Negative 5.
Yeah, because that negative. So the next step, please, if you write this, if it's on a test or a quiz, I'm going to take some points off. You didn't show me what you did. And I understand. I know you guys are like, well, I can just see the damn thing. I don't care. I need to see the steps. All right, so what is the official step? Divided by 6. Yeah, good. Right? Is that cool? Okay. I'm going to get a little less stringent on that. You can start skipping some steps later, but for right now, I really want you guys, everybody, to be fully aware of what all the steps are. Because sometimes your brain will tell you the answer, but you didn't see the steps. So when it gets more complicated, you won't know what the hell to do. Your brain will say, like, I'm going to sit this one out. I'm not really sure. You have fun with it. You're like, shit. You guys understand? So right now, if you're able to look at a problem and just kind of see what the answer is, that's nice. You're here to learn the algebra, the procedure, so that when the equations get really ugly and your brain just says, I don't think so, you'll know how to attack it with the procedure. So don't worry, brain. Just sit back. Yeah, take a back seat. All right. So let's get into, anything else there? We're going to get into chapter 4. Is that what you're talking about? And I'm going to introduce this in a way, let's see how this works. We're going to start off very conceptual, and then I'm going to work our way into very technical, like the technical details of how to work a problem out. But I want to start with the idea of fractions. So, kind of like to do this example of, and I kind of joke always about eggs. Maybe I like scrambled eggs and all that kind of stuff. If you eat eggs directly, I always say, man, that's one cake that could have been made. Eggs are for cakes. I hate eggs directly. Right? My grandparents one time forced me to eat eggs, and I was like, no.
Uncooked?
Huh? That would be even worse. Right? I don't like fish, so like sushi is like extra evil. Right? So eggs, no. So say I have an egg carton that fits 8 eggs, right? So you can see 8 empty spots up there, right? Is that cool? So to fill that carton, to have one full carton, how many eggs would I have to put in there? 8. Cool. So if I only have 1 egg sitting in there, right? I'm not sure what happened to my egg. Leave it alone. If I only have one egg sitting in there, how much of the carton is full? Is it a full one?
1/8.
Yeah, it's 1/8. So I know it's got to be a number less than 1, because to make a full 1, it would take 8 freaking eggs. So this is a visual representation of the fraction 1/8. 1/8 of the carton is full. Right? How are we doing so far? Is that a decent number? You guys should be maybe okay with fractions, but fractions normally is the next thing after word problems that people really hate. Yes, sir?
What if we take all of it? With the weapon, it's 4 of 8, so 8 and 8,
Say again?
it's 4 of 8 eggs.
Well, there's 4 eggs, okay. So what do I put in there? I got eggs up here, right?
That'd be 4 and 4.
4 out of what?
4 and 8.
4 out of
8.
8, exactly. It would be 4 out of 8.
Nah.
4. How?
And if you look at it a different way, how much of the carton is full?
1/2.
Exactly half. So somehow 4/8 is the same thing as 1/2. Of course, a lot of you guys should probably know how that works. We're not officially there yet, so I'm just going to hold off on that. How are we doing so far? I mean, this shouldn't be too evil. Okay. Decent. Now, so let's go a little step further. So if I put 8 eggs in there,
8 and 8.
1.
that'll be 8 out of 8, that's 1. I love it. Cool. All right. So if I put all 8 eggs, 8 out of 8 is just 1. So now I got one full carton, thankfully. Finally, I got a full carton of eggs. I can make a lot of cakes. Kick ass. All right. So let's take the next step up. So what if I have this situation here?
Wow.
Okay. Yeah, I got a lot of eggs. That's right.
Likes cake.
So this is one situation. So what do I got? I got
8. 1.
1,
1.
2,
2/3.
and
2 8.
3
Okay.
8s. I got 1, 1, 3 8. So altogether I have 2 3/8 cartons full, right? It's definitely not a full 3. And it's definitely not just 2. So it's something in between 2 and 3. That's what 2 3/8 is. 2 3/8 is almost 2.5 if I would have just had one more egg. Are you with me? How are we doing so far? Is that decent? I don't want to play poker with any of you guys. I will not let you know. Okay.
Is there multiplication between the 2 and 3?
No. I like the question. If I want to say 2 times 3/8, I have to say this. You ready? But really, how did I get here? What did I do with these? What did I do to get to that number? Added them. So this, I completely agree with what you're thinking. This is an evil notation, and unfortunately, we just weren't there when they created it. So we couldn't say, dudes, that looks like multiplication is going to freak people out. But what this really means is 2 and 3/8. It hides the plus sign. It's not 2 times 3/8. It is 2 and plus 3/8. That's sure.
But like if we want, like we multiply 8 by 2.
No, careful. That's a process that gets us somewhere. I'm not there yet. I'll show you where that comes from. Right? Now, what's another way to look at this? Isn't this 8 out of 8?
Yes.
Isn't this another 8 out of 8?
Yes.
So how many out of 8s do I have total? I have 8. 8 is 16.
19.
I have 19 8s total, right? That's 8 up there, another 8 down there, another 3 is 19 8s total. I'll let you absorb that for a second.
Why is it still?
I'll show you.
8?
I'll tell you why. You ready? All right, let's take this. What's that one by itself again?
1 8.
1 8. I love it. So if I had my cards are getting worse and worse. If I had this, isn't that 1/8 and another 1/8 makes
2 8.
2 8s? Right? So if each individual egg represents 1/8 of a carton, couldn't I just add them all up? 8, 16, 19, eighths, because they're each an eighth of a card. Yes, sir?
What happens if you did like all eights? That'd be third eight, that'd be 8 and 8 do like 8 for 24.
Yes, exactly. If I filled them all up, it'd be 24 divided by 8. What's 24 divided by 8?
4.
3, because that would be 3 full cartons.
Three.
That'd be 3 full cartons. So let me ask you this. Let me take a step back. If this is a pizza, and there was this much of it left, this has still got pizza on it. How much of the pizza is there?
Ones.
Half, right? So then this much represents 1/2. So what if I had this situation here?
2 halves.
One.
1/2.
How much total do I have?
2 and a
One
half.
and a half.
1.5.
I have 1 full and a half, or how many halves do I have?
3 halves.
1, 2, 3 halves. How many eighths do I have? 8, 16, 19 eighths. Because each spot represents an eighth. Now here's the connection. Here's where some of you guys were going earlier. So what I'm saying is 2 and 3 eighths somehow is the same thing as 19 eighths. This is what I'm claiming. Good. Let's go on. No. So some of you guys, of course, know how to do the shortcut, but let's attack this one first. How do I do 19 eighths? How do I do math to that by itself? What does that really represent? Division. So, real quick, do 8 into 19 for me.
2.
I like it. 2.
16.
So it's maybe 3.
That's 2 and
Third.
3/8.
3 eighths. So sure enough, if I convert 19 eighths, if I actually do the division, it becomes 2 and 3 eighths. Yes, sir.
So if I did my homework to where it said 19/8, that's wrong.
It depends on what they ask you. If they say leave your answer as what's called an improper fraction, right? That's what's called an improper fraction because the top is at least as big as the bottom is. A proper fraction would be something like 5/6, something smaller than 1. So if the top is at least as big as the bottom, that's what's called improper. It's top heavy. It's some number bigger than 1. How you guys doing? Anybody remember what we call this kind of number here?
2 to 3.
3 eighths is a fraction. What kind of number is 2?
Whole.
Whole number. So is it one kind of number? No, it's a mixture of numbers, right? So it's what's called, incredibly enough, a mixed number. I know that should sound familiar to a few of you guys, right? Mixed numbers versus improper fractions. That sound at all familiar? Okay. But do you see how they agree with each other? When I do the division, I get exactly what this is. And actually, let me do this a different way. What if I take 19 over 8? See if you guys are cool with this. Does 8 go into 19 evenly?
No.
No, that's why it's ugly, right? What's the next lower number from 19 that 8 actually goes into?
2.
16, so you're thinking ahead. So what is 19? 19 is 16 plus 3, isn't it? So anywhere I want to in the universe, if I see 19, I can replace it with a 16 plus 3 if I really feel like it.
How
Yes,
can that be 16 plus 3?
What is 16 plus 3?
19.
So then 19 is 6 plus 3. Cool. Now in this setup here, what is being divided by 8? 16
19.
and 3. Right? So I could say this is 16 divided by 8 and 3 divided by 8. We stop right there. How are we doing? Yes, sir.
Do we add those?
Sort of.
19 and 8?
No, not quite.
Oh,
Not 19, but what's 16 divided by 8? 2. And that's 2 and 3 eighths. So the 3, the and 3 eighths, that represents how much extra, how much over 16 you've got. Why is 16 special? Because it's divisible by 8. So let me ask you this. All right. Let's see. So if I had a full A card, that would be 8 out of 8, right?
That'd be
So if I add one more egg on top of that, bam.
2 and 8 and 9.
What does this represent?
And 1.
1 8.
So how many eights do I have altogether?
9.
9 eighths. Okay. So isn't 9 eighths? That means you have one extra. Right? If only it was 8 eighths, it would go in evenly. 8 goes in 8 once. So I was thinking about like an odometer. Once you reach something, doesn't it roll over? So once it's like 1 eighth, 2 eighths, 3 eighths. Once it gets to 8 eighths, it rolls over. Now the next one starts to get filled up. Then it's 1 and 1 eighth, 1 and 2 eighths. Let me write this a little better. 1 and 1 eighth, 1 and 2 eighths. Once it gets to 1 and 8 eighths, it rolls over.
2.
What the hell is 1 and 8 eighths?
It's a whole number 2.
It's 2. I love it because 1 and 8 eighths, that's 1 and 1. It's a full 2. So I always think about it like that, rolling over. Yeah.
So it adds up, so that's be 2 eighths, and then that's like 2 8 eighths, like 1 8 eighths, 2 8 eighths, and then 3
Yeah, 1 eighths, 2 eighths, 3 eighths,
4 8 5
4, 5, 6, 7, 8, 9 eighths.
10 11.
Well, it's the same thing as 1 and 1 eighth.
1 and 1 8.
Cool. All right, so this is the concept part of this. Hope you guys kind of get what I'm saying. And really, I want you to really realize the worst thing about fractions, of course, is you got to do something different when you're adding, subtracting versus when you're multiplying, dividing. And here's really why. I think from this discussion you can pick up what's 1 eighth plus 3 eighths.
4 8.
Now, why is that so damn easy? Because I got 1 something plus 3 of the same thing is 4 of those things, right? Just like 1x plus 3x is 4x. So when they have the same bottom, they are like terms. I'm allowed to put them together. When fractions get evil is when you're trying to combine things that don't have the same bottom, right? That's when you start to go, oh shit, I've got to do something to make them the same. So if I had this problem, x plus 3b, can you do anything?
No.
No, I can't do a damn thing. But if I had 1 eighths plus 3 fourths, there actually is something I can do. Right now, this is 1 of something plus 3 of something else. Please, dear God, don't try to tell me that's 4 twelfths. What did somebody do that tells me that?
Add it up all the way across.
Yeah, I got 1 eighth and I got 3 fourths. How in the world? I don't see any twelfths over there. I don't see anything over 12. How do you have 4 of them? I know, so that's a mistake they made. Good. So that's a mistake they made, right? You can't add these the way they are because they're not like terms. They're like 1x plus 3b, something else. Okay, so that's coming up here in a bit. But right now we've got nothing but like terms. They're all out of 8. So that's why I'm able to put those together no problem.
Can I ask a question?
Yeah.
How would you know when would it turn into like 9/16 or when you have your egg cartons, like when do you know it's different? The denominator is going to be different.
I would have to have, so if I had a carton, and this is very difficult to do with eggs.
Okay.
But if I could cut all the eggs in half, now how many spots do I have?
16.
16. So my analogy goes a little south, because cutting an egg in half is like trying to bend a potato chip, right?
Yeah.
Unless your potato chip's really damn old. If you can bend them, you probably should throw it away. But yeah, that would be the visualization, the physical reality of how to get to 16ths. I had to cut all the eggs in half,
Okay.
right? Yeah.
Would that be okay? So if you do that, but do you like make 8 more?
No. So at some point I want to get away from the visualization of this stuff, but I want to tie in how the eggs makes physical sense and how that ties into the math that we do. So then we got worse and worse fractions to deal with. I don't want to always have to draw a carton. So if I had 3 70ths, I don't want you to draw some big-ass thing with 70 spots in it and fill in 3 of them. You with me? I want us to get away from that because it's not helpful after the initial idea. Right? So the idea that we really get directly from those egg cartons is how to go from mixed numbers to and back and forth improper fractions. Freaky. Yes, sir.
But he says show the look. I'm not trying to get smart ass or something. He says show the look.
Yeah.
How are you going to show the look if we have like fractions?
We're not there yet. So far I've only discussed really the concept behind it. So now I'm going to show you what the work looks like. Right. So for this problem here, if I have, let's start this way because we know what to do here. If I have 11 over 7, how would I convert that back to a mixed number? Can somebody estimate for me what that is? Just give me an estimate of what 11 sevenths is. What is it between?
7, then
2, 1 and 2.
It's between 1 and 2. Because if the top was 7, that would be 1. If the top was 14, that would be 2. 11's right in between, so it's somewhere in between 1 and 2. I like it. So how do you convert that into a mixed number? What do I do with this? Yeah, I do what it actually means. That division bar, that the fraction bar is division. So 7 goes into 11? Once. With 4 left over. I like it. And you can see that. Why is the top not 7? How much extra does it have?
4.
4. It's got 4 extra. That's exactly what this piece means. It's got 4 extra. You kind of with me? Okay, good. I know there's probably several of you out there that are like, oh my God. So it's cool if you know fractions entirely. That's sweet. So just continue doing what you're doing. I like it. If you don't know fractions really well, I'm hoping to God this is getting you a little bit better feel as to what fractions are all about. What about the other way, though? What if I had a mixed number? Here's problem number 1. How do I go from a mixed number, 3 and 2/9? I want to go to an improper fraction. Yes, sir.
So multiplying 9 by 3 and with 2 like we do sum, right?
Yes, well, sort of. So the shortcut, what do you do when you divide? Let me ask you this. What operations do you actually do when you divide? You do subtraction and obviously division, right? So when you want to go backwards, I'm going to do multiplication and addition. So let me ask you this. Let me really analyze this way more than some of you guys want me to. If I had 9 spots, right? That's that. Out of 9, you with me? Out of 9 spots. So to represent that visually, it would look like this. Let's see. We have this is the most exciting thing you've ever seen. You don't know how to contain yourself. Okay. So is that right? Did I do that correctly? I might be tricking you. Is that an accurate representation of 3 and 2/9?
Yes.
Yeah, 3 full ones, and then 2 out of 9, right? So that's 3 and 2/9. Cool. Which way was I going to go with this? Okay. So, remind me again, this is 9/9, right? Mm-hmm. This is 9/9. Yep. 9/9. 2/9. Cool. I like it. So, which way I want to go with this? Isn't this going to be, how much does this by itself represent? How many ninths are these 3 together?
3.
27 ninths, right? Isn't that 9 ninths? 9 more is 18 ninths. 9 more is 27 ninths. Are you guys kind of with me? And what do I really mean by this? I still think some of you guys are not understanding. If I said I had 9 is something, plus 9 is something else, plus 9 is something else, how many of those things do I have? 27 of them. And each one of these spots represents a ninth. So if I have 9 ninths plus 9 ninths plus 9 ninths, how many ninths is that?
27.
27 ninths. 27 over 9, I like it. Right? So it's the idea of like terms. Every spot is ninth. I can add all of them because they all represent some ninths. So 9 of them, 9 of them, 9 of them is 27 of them. 27 ninths. Now, do you see where that, why is it 27? How many of these do I have?
9.
3. Right? I got 3. Each one is 9. So 3 times 9 is 27. And then what do I do with this? That's not the total, right? I haven't added these in yet. So I pretty much just told you. What do I do with these? Add them in. I got to add them in. I haven't counted them yet, right? So I have to add in 2. So that should be 29 ninths. Now here's the shortcut. Isn't this 3 full things of 9 each? And doesn't that, how do I know there were 9? How did I know to draw it like this? Because the bottom told me that. So aren't I going to have 3 of these? Isn't that multiplied 9 times 3 is 27? And then I have to add in the 2 I haven't counted yet? So plus 2, so this is times. 9 times 3 is 27. Plus 2, 29 ninths. So that's the process. And what operations? I used multiplication and addition. Up here I use division and subtraction. It kind of makes sense. To do the opposite procedure, I use the opposite operations. Yes, sir?
So that's 3 and 29 to 9.
No. The 3 kind of got sucked in. 9 times 3 is 27. That's the 3 right there. That's the 3 of them. Makes 27 ninths total. Plus the 2 ninths that are sitting out here by themselves makes 29 ninths total. So 3 and 2 ninths is the same thing as 29 ninths. Those are the same thing. Yes, sir?
So if you had to simplify it, it would be 3 and 2 ninths.
I like it. So if I started here and I said simplify, you could do this. But there's also a question of, I could say, rewrite this as an improper fraction. Then you have to know how to do this, to go backwards. You with me?
So first you divided by the 9.
No, I multiply. 9 times 3
27,
plus 2.
29,
Good. And if I want to check it, 9 goes into 29 how many times?
10,
No.
2, 3,
Okay. 3 times 9?
27, and the remainder 2.
So 3 and 2 ninths. Sure enough, that is that, right? 3 and 2 ninths. So here, let me shut the hell up for a second. I've been talking a lot. You guys do these problems. Convert it to the other form. So convert these. Don't convert them to your religion or something. Just convert it from mixed numbers to improper. I want to see that. This fraction is now Jewish. So if I had... Alright. So do those 3. Call me up if you need some help.
So what's the first number? 2 of 7?
Yeah, 1 and 2 sevenths. Yeah. So how do we do this first one here? What are the steps to take?
Multiply 7
Yes.
times
7
1.
times 1, 7.
7 plus 2,
Plus 2.
9.
Now be careful. I always get somebody tell me that, and they just stop. And I'm like, holy crap, 1 and 2 sevens is 9. Neat.
7s.
Yeah, good. 9 sevens. Don't leave the little dude on the bottom out. 9 sevens is just barely over 1. Is that cool? 9 divided by 7 is 1 point something or other. So that agrees with barely over 1. 1 and 2 sevens, just a little bit over 1. So you got to make sure your answer makes sense. If you put a 9 there, it doesn't make any sense. Right?
So you go 7 times that plus 2.
I like it. And here's a whole other way to look at this.
Always. You do that.
Yeah. Because remember, what does this really mean? What operation is hiding in the middle? Plus. Now be careful. This process is not... What is 1 times 2 sevens?
2 7.
2 sevens?
14.
No, what's 1 times 2 sevens? What's 1 times any damn thing?
1.
Any damn thing?
This number.
It's whatever it is. 1 times 4 is 4. 1 times 8 is 1 times 2 sevens is.
2 7.
Is that what we got?
No.
So this can't be multiplication. Are you with me? This is actually addition. Let me show you why. Can I add these two?
Yep.
No, not the way they are.
Yeah, we can.
What is this over right now? What is 1 being divided? What's it over?
1.
One.
Let me stop right there. You guys cool with that? Any whole number is over 1. If you have just 8 sitting there, if it's divided by 1, did I change it? No. So it's the easiest way to make 8 into a fraction is it's 8 over 1. Right? So why the hell did I do that?
We can make a 7 by 7.
I don't know. Here's a really good a full thing that has 7 parts. Well, how are you gonna make 7 parts? So if I had 7 parts, 1, 2, 3, 4, 5, 6, 7. If it was full, that would be how many sevens?
7 7.
7 sevens. So wouldn't this become 7 sevens? Isn't that what 1 is? With me? 1 is 7 divided by 7, isn't it? So what is 7 sevens plus 2 sevens?
9
9 sevens. Now stay with me, stay with me. This is kind of cool. So if I had 1 and 3/8, that's 1 plus 3/8. What's 1 in terms of the spots that this talks about? What is a full thing? How many spots does a thing have? 8. So a full thing would be 8/8. So you see how the 1 is going to multiply by whatever the hell is down there to match up with it. You with me? So that's why this makes sense. 7 times 1, because that's how I get there. If it was this, it'd be 8 times 1, because that's how I get there. And then what do you do with the 3? You add it, because that's what it needs to do. That's why the shortcut works. 8 times 1 plus 3, 11/8. For that problem, right? So here, 7 times 1 plus 2, 9 sevens. It's just a shortcut of all of this work here. And I showed you a whole other reason why it works that way, but this is an actually very direct reason why it works that way. Now, how do you go this way?
Divided.
5 and 6, 7.
I love it. And think about this. 41 is almost a nice number for 7. What would have been better if I would have just put a 42? Why the hell didn't I do that? 42 divided by 7 is 6. So let me see if some of you guys get this. How close to being a full 6 am I?
Pretty near.
Pretty damn near. It's true. Exactly how far away am I from being a full number 6?
1 7.
1/7. Now listen. Didn't you tell me if only I had 41 sevens and I added 1 sevens, wouldn't that be 42 sevens? So isn't 41 sevens 1/7 less than 6? I know I'm throwing a lot at you. But these are all, if you can, there's more than just the process. There's the whole idea of what's going on behind it. So if I had 6, if my tank had 6 gallons in it, I don't know what kind of thing I'm driving, but my tank is 6 gallons. I guess it gets 800 miles a gallon. So I have 6 gallons, and I drive enough to have 1/7 of a gallon go away. How many gallons do I have left? That's a neat question, right? That's what we're actually figuring out. So I'd have this really, wouldn't I? 42 sevens is 6. minus 1/7 is 41/7. So it should be a little bit less than 6. And when you do the work, 5. So sure enough, it's 5 and 6/7. And what do you get when you add 1/7 to this?
6,
Six.
7.
5 and 6/7 plus 1/7 is 5 and 7/7. Isn't that 5 and 1?
Yes.
That would be a full 6. So I know there's a lot coming at you, especially if you're not that comfortable with fractions. But if you're catching on to any of this stuff, it will help you out with dealing with fractions. If you understand how they work. Yeah.
So,
So you can always rely on the process. If you don't quite get the other stuff I'm talking about, right now that's fine. Do you understand the process? If I divide, I get there, don't I? And I think you're cool with that. I've seen you do this. Yeah.
that's 5 and 6, 7. Because
Yes.
that's 5, so 7 times 5 is
35.
And then the remainder
6
is
left over.
Like 7,
See, so you're fine.
7 6/5.
Well, got the wrong numbers in the wrong place, but 5 and 6/7, right? 5 and 6/7. So you know how to do that. I know you do. All this other stuff is just neat if you understand it. That means you understand fractions that much better. But for right now, I really just need you to be able to do the process.
So that's
And the
how
rest
you-
of it should hopefully
so
come
that's
in.
how you start the work?
That's how you go from here to here. I love it. Do this work.
Okay.
So how do you go back again? Let's do another one of these.
7 times 11.
Yes, 7 times 11.
77.
77 plus 2.
79.
79 over 7. And sure enough, you can check real quick. 7 goes into 77 11 times with the 2 left over. Because you have 79, not 77. You have 2 left over at the end. How are we doing? So that remainder actually tells you how far away from going in evenly you were.
Can you, like, the remainder, so if remainder is like, okay, like that, so can we put 2s and thirds? Like 7 and 2s and thirds?
You can't have thirds because there's no thirds here. It's 7s, right? So you can't just bring a 3 in.
So 1 and 2s, 1 and half. So 37 and a half.
No. It'd be 77 plus 2. That's why it comes out to 79. Okay. All right. Let me see. Oh, I want to do a little bit out of there, but I tell you what. I don't know if you can tell. I don't think you can tell, but I'm feeling really bad, and I'm starting to feel worse. So I think I'm going to cut class short. I'm doing a good job of hiding it, I think, but my head is about to explode. So hopefully I'm not catching something. So that's enough for today. I think I'll stop there. This is section 4.1. So next time we'll pick up from there and get into 4.2. Okay.
So on adding, you just don't add the bottom numbers. That all stays the same if they're the same number.